the question related to atomic physics, the block 5. Bismuth, which is a radioactive, which has a half-life of 20 minutes. The nuclide notation of a bismuth is given. It is 214 and 83. What is the composition of a nucleus? Composition of a nucleus, you are not supposed to write electron because electron does not exist in the nucleus. So how many protons will be there? And how many neutrons will be there? So you just subtract. Then it emit out a beta. Whenever the beta emission is there, what happened to a nucleon number? Stays the same. And what happened to proton number? Increases by 1. Because the one of the neutron breaks into proton and electron, and that proton number increases. So nucleon number does not change, proton increases by 1. The count rate of a bismuth is 360 counts per second. And already in the beginning of question, they mentioned the half-life is 20 minutes. So what will the count rate after 60 minutes? Right now we have 360. After 20 minutes, it will be 180. After another 20 minutes, it will be 90. After another 20 minutes, it will be 45. So 45 counts per second. Counts per second is a unit here. You're not supposed to try to change the units, okay? Even though this is given in minutes and this is per second. But that is for a counter, it is the unit for the counter, not for the half-life. State 2 social, economic or environmental issues involved in storing a radioactive material for a very long half-life. If a radioactive material has a very long half-life, what might be a social issue? Because if it is having a very long half-life, what will happen? That place will not have so many visits. Like the people will not prefer to go there because that place is near radioactive source emissions are there. Another environmental issue, like it can cause a mutation. That is environmental issue you can mention. And same thing, the economic issue refers to, like, if it is a tourist place, lack of tourists will be there in that place, reduce the tourism, land value will decrease. Yeah, that's right. Risk of cancer is also there, the social issue. It's an open response question, so means variety of answers are acceptable for this. Use the readings, the background counts, and determine the half-life. How many background counts are there? You can see this part almost in this region, it become constant. So you will take an average. It will be about 20. For example, 20 are the background. Then we have to determine the half-life. So how to determine the detector reading is 324. If the total reading is 324, 20 are the background. How many radiations are due to source? So means the source radiation will be 304. After half-life, the source radiation will be 152. And the background count won't change. It will remain 20. So the count rate will be 172. Then after another half-life, it will be half of this. So it will be 76. And the background count will remain 20. So it means 96. So how many half-lives will pass when the radiation changes from 324 to 96? So how many half-lives are there? 2 half-lives. So means this interval is for 2 half-life, which is 1 hour. So 1 hour is a duration for 2 half-life. What is 1 half-life? So it will be 1 divided by 2, or half an hour. So half-life is equals to 0.5 hours, or you can say 30 minutes. You can choose any, or you can take an average. Like on average, like 20s or 21, you can take any one of them. You can take. It's even mod. You can also take a mod for the background radiation. Is it clear, this one?